So let's look at the first question. All right. So we've got 2a cubed over 8a squared. Now what you want to do is you want to simplify the numbers and the like terms. So 2 over 8, well, I'll do it in red. That can just simplify to 1 over 4. Now we've got a cubed over a squared. Now obviously a cubed is bigger than a squared. If we cancel out the 2 and take, well, we went 3 minus 2, we're just left with 1. So that means we're left with an a up top. So we've got a over 4. So you can rewrite this as a over 4 or 1a over 4, but remember we never write the 1 in front of the a, so a over 4. Next one over here, we've got 9x to the power of 5 over 12x squared y. So again, we simplify the number first, so 9 over 12, we can simplify that to 3/4, so we can simplify this to 3 over 4. And then we've got x to the power of 5 over x squared, so that's just x to the power of 3 if we cancel out. So we've got 3x to the power of 3 over 4. Now, because there's no y on top and there's a y down the bottom, we're just left with y down the bottom. Right? So that's how we simplify the second one. The third one, we've got 5a squared b over 15, a to the power of 4b. Simplify the number first. 5 over 15, we can simplify that to 1/3. So if we divide both by 5, we can simplify that to 1 over 3. We've got a to the power of 2 over a to the power of 4. So that's just a to the power of -2. If we write it up top, and then b over b is just 1. Now if we simplify this, we don't like negative exponents. So we can write this as 1 over 3a squared. So if you've got a negative exponent up top, you can bring it down, it becomes a positive exponent. Right, so we don't like writing negative exponents, that's why we write it as 1 over 3a squared. Cool. Let's look at the factorizing one. Right, so factorizing a common factor in the first one, we've got 5x as a common factor. If I take 5x out, if I divide 5x squared by 5x, I'm just left with x. And if I divide negative 15x by 5x, I'm left with -3. Okay, and you put the x minus 3 in brackets. Alright, next one, we've got a quadratic equation. We want to look at two numbers that multiply to -8 but add to +6. Well, we can look at the factors of 8, or not in -8, sorry, 8. Factors of 8, so we've got 8 times 1, we've got 4 times 2. Alright, and obviously if I went 8 plus 1, well that's 9. And 4 plus 2 is 6. So I can just write this as x plus 4, x plus 2 in brackets. Okay, and if you want, you can expand this bracket to see if it goes back to your original function. Next one over here, we've got another quadratic with it's 3x squared plus 13x minus 10. I'll multiply the 3 with the -10. So I've got 3 times -10. That equals -30. Now I want to look at the factors of -30. So I've got -30 times 1. I can have -15 times 2. I could have 30 times 1. No, -1, sorry. I could have 15 times -2. I could have 10 times -3. I could have -10 times 3. I could have 5 times 6. I could have 5 times -6 or -5 times 6. So I'll look at all of these and see which two add up to 13. Now if I look over here, well 15 plus, or minus 2 is 13. So I can split this up. I can write this as 3x squared plus 15x minus 2x minus 10. So I split up the middle term and then I factorize in groups. So I can take 3x out as a common factor for the first two. I'm left with x plus 5. I can take -2 out as a common factor for the next group, and I'm left with x plus 5. And if I take out x plus 5 as a common factor, I'm left with 3x minus 2. Right, and that's my final answer over there, once I have factorized this. Right? So factorizing the exponents are really important when it comes to rational expressions. So we'll go over a few examples of rational expressions and try simplify them. Right? We're not solving, we're simplifying, because if we're solving, we'll have equal to something. Because we don't have equal to something, we're just simplifying. So looking at this first one over here, we've got x squared minus 9 over x minus 3. So we want to factorize the top. All right, really important. Now, if you look at that, all right, that is just a difference between two squares. All right, so if we're trying to factorize this, we're looking at a difference between two squares. So I can just go, well, two numbers that multiply are negative 9, but add up to 0. Well, we know that negative 3 times 3 equals negative 9, and negative 3 plus 3 equals 0. So I can factorize that as x minus 3 and x plus 3 over x minus 3. Now, I've put it under brackets because I'm going to cancel these terms out. I've got x minus 3 up top and x minus 3 down the bottom. So if I cancel these two things out, all I'm left with is x plus 3 over 1, which is x plus 3. Simplified. Cool. The next question, I've got 3x squared plus 6x over x squared minus 2x minus 8. Alright, so again, we'll factorize the top. If I took 3x out as a common factor, I'm left with x. And if I took 3x out of 6x, I'm left with plus 2. Then I factorize the bottom. So two numbers that multiply to negative 8, but add to negative 2. So I can have negative 4 times positive 2. That equals negative 8. And negative 4 plus 2 equals negative 2. So then I can write this out as x minus 4, x plus 2. I can cancel out the x plus 2, so I'm just left with 3x over x minus 4. Cool. Next one over here, up top, I've got 9x squared minus 4 over 3x squared plus 13x minus 10. Now we've done this 3x squared plus 13x minus 10 just before up here, so I'm not going to refactorize that. I'll just use that answer there. But I want to factorize the top. Alright, so I can't take out a common factor, but again, it's a difference between two squares. So what I'm looking at is, I'm looking at something along the lines of this 3x, I'm looking at a plus and a minus, because I haven't got a middle term. So now I look at because obviously I did 3x, because 3x times 3x is 9x squared. So I'm looking at two numbers that multiply to negative 4 and have to be the exact, well, not the exact same number, but you get the idea. There's a positive negative. So we know that's, well, 2 times negative 2 equals negative 4, and 2 minus 2 is 0. So this becomes plus 2 minus 2 up top. Alright, and down the bottom, I've already factorized that. I had x plus 5 over 3x minus 2. The 3x minus 2's cancel out, so I'm left with 3x plus 2 over x plus 5. Alright, so that's how I simplify that over there. Cool? So now we've got these two over here. Alright, so look at the one with x squared minus 7x plus 12 in brackets and x minus 3 to the power of negative 2. So what I could do is I could just rewrite this as x squared minus 7x plus 12 over x minus 3 squared. Alright, because that's a negative exponent, so I can put it under as a fraction to make it a positive. Now let's factorize the top. So I want two numbers that multiply to 12 but add to negative 7. Now because I've got a positive number and a negative number in between, I'm looking at two negative numbers. Right? So two negative numbers. So I know that negative 12 times negative 1 equals positive 12. I've got negative 6 times negative 2 equals positive 12. I've got negative 4 times negative 3 equals positive 12 as well. Now looking at these factors over here, the two numbers that add up to negative 7 are these two right here. So I know I'm going to have x minus 4 and x minus 3 over x minus 3 squared. Now because I want to cancel this out, I've got an x minus 3 up top and I've got x minus 3 squared down the bottom. So I'm going to get rid of one of those. So I'm just left with x minus 4 over x minus 3. And that is my answer. simplified. Cool. Next question, we've got 4 over x minus 3 multiplied by x squared minus x minus 6 over x plus 2 squared. Now before I multiply that, I'll leave this as it is over here. I would actually factorize the top. So I'll leave the bottom as it is. X plus 2 squared. I'm looking at two numbers that multiply to negative 6 but add to negative 1. Well, negative 6, I can have negative 3 times 2. I can have negative 6 times 1. Well, if I want to get negative 1, well, negative 3 plus 2 equals negative 1. So I know I'm going to have x minus 3 over x plus 2. Now, before we multiply that again, we can just realize and go, oh, well, actually, I can cancel out x plus 2 and x plus 2 down there. So I'm left with 4 over x minus 3 multiplied by x minus 3 over x plus 2. Now what you do is, because you're multiplying, you can merge them together and go 4 bracket x minus 3 over x minus 3 x plus 2, because we're multiplying. And you can go, well, I can actually cancel out the x minus 3's as out, so all I'm left with is 4 over x plus 2. The next two questions I've got 4 over x minus 3 divided by 8x over x minus 3. Again, remember with something like this, you can flip the fraction to make it, to multiply it. So I will have x minus 3 over 8x. Well, I don't have to merge them together. I can just cancel out the x minus 3's because it's multiplied. So I'm left with 4 over 8x. I can simplify this further. If I divide both the numbers by 4, I'm left with 1 over 2. Oh, not 4x, sorry, 2x. Cool. Next question, same thing, because it's divided, or we're dividing, we flip the fraction, so I'm going to have x squared y over x minus 3 squared multiplied by 5x minus 15 over y. Now I can just cancel the two y's out, first thing, by looking at it. So I'm left with x squared over x minus 3 squared multiplied by 5x minus 15 over 1. I can factorize the top over there, the 5x minus 15, so I'm left with x squared over x minus 3 squared multiplied. Take 5 out as a common factor. Got x minus 3 over 1. I can cancel out the x minus 3's, so all I am left with when I multiply now, I've got 5x squared x minus 3. Right? That is how I simplify that. Cool. Now these are the last two questions I'll go over. So now we're adding fractions or subtracting fractions. So again with rational expressions, we want to get a common denominator. So I've got 2x minus 1 over 4x plus 7 over 6x. Now to get a common denominator, what I could do is I could just multiply both sides by 6x over 6x, and this side by, not both sides, why am I saying both sides? The terms by the opposite denominators, right? You could do that, right? Or what you could do is, the other option is just multiply it by the numbers, because you have x's in both. So x is already common in both denominators, you can just multiply it by the numbers to make it easier. You can go 6 over 6 and 4 over 4. You can do that as well. Right, so if I've got 6 bracket 2x minus 1 over 24x plus 28 over 24x. Alright, now because they're under the same denominator, I could put them up, I can put them under one fraction. But I'll first multiply this out. I've got 6 times 2x, which is 12x, minus 6 plus 28 over 24x. Right. Now I would add my like terms. So I've got 12x plus 22 over 24x. Now take out a common factor. Right. We can take out 2. We'll take out 2 as a common factor. So we're left with 6x x plus 11 over 24x. Right, and I can now simplify the 2 and 24. So I'm going to have 6x plus 11 over 12x. And that's my solution simplified. Cool. The next question I had over here was 8 over x plus 3 minus 3 over x plus 1. We'll do the exact same thing. We'll multiply by the opposite denominator, or not the opposite denominator, the denominator from the other term. So we'll have 8 over x plus 3 multiplied by x plus 1 over x plus 1. Now if you realize x plus 1 over x plus 1 is actually just 1 simplified, but we're multiplying it with that. Minus 3 over x plus 1 multiplied by x plus 3 over x plus 3. Now we simplify, we'll have 8 bracket x plus 1 minus 3 bracket x plus 3 all over the same denominator of x plus 3 and x plus 1, because we've got a common denominator now. Alright, now we expand it out, so we get 8x plus 8 minus 3x minus 9 all over x plus 3 and x plus 1. We add our like terms, or add or subtract our like terms, so we get 5x minus 1 over x plus 3 and x plus 1. Now if you look at this, you can expand this if you really want to, but obviously by expanding it you're not going to simplify it any further. So this is the most simplified answer we're going to get. So that is our final solution right there. Alright.